Okay, this is lesson 15.2, which is going to be the volume of a cone. Starts on page 680 in your textbook, the volume of a cone. So just like on our last lesson, for volume of a cylinder, which is basically a circular prism, we use the same formula, volume equals base times height. Well, this is a volume of a cone, and a cone is just a circular pyramid. And remember, for a pyramid, we had volume equals 1/3 the area of the base times the height. That was for a pyramid. Well, for a cone, we're going to have the same thing. Volume equals 1/3 area of the base times the height. But the base will always be a circle. So we can fill in the area of the base with, instead of b, we'll put pi r squared, just like in our last lesson we substituted area of the base with pi r squared times height. Here's the formula we'll be using for this section. Sometimes they'll be asking us to solve for the volume, and sometimes they'll give us the volume and ask us to solve for the height, just like in our last lesson. So let's take a look at the first example they give us. They give us one that looks like this green cone right here. And they want to know its volume. So we put volume equals 1/3 pi r squared times the height. And the radius, or here we can put 1/3 times pi. The radius is not 4. The radius is only going to be 2. So 2 squared times the height, which is 6. So now I have 1/3, 2 squared is 4 times pi, so 4 pi times 6. Now I'm going to do the 1/3 of the 6. 1/3 of 6 is 2. So now I have 2 times 4 pi, which is just 8 pi, and it's cubic meters. For the second example, they're looking for the height, just like in our last section. And this time, we'll use volume equals 1/3 pi r squared times height. And they give us the volume. So the volume is 956 equals 1/3 times pi. The radius is 9. So 9 squared times the height. 956 equals 1/3 times 81 pi. 9 squared is 81 pi times the height. And 1/3 of 81 is 27. So I have 956 equals 27 pi times the height. Well, I divide both sides by 27 pi. And I'm stuck with 956 over 27 pi. There is nothing that can go into 27 and 956, so that's as simple as we're going to get it, keeping it in terms of pi. And remember, we solved for the height, so this is just feet, not feet cubed, just feet, because it was the height. For the on-your-own problems, number 1, we have volume equals 1/3 pi r squared times the height. And we're looking for the volume. So we put 1/3 times pi. The radius is 6 times the height is 15. So substitute in. Now simplify. So 1/3 times 6 times 6 is 36, so 36 pi times 15. I could take 1/3 of either of these, so I'll do of the 36, leaving me with 12 pi. I don't know why I put the pi first. 12 pi times 15, which is 180 pi. So the volume is 180 pi cubic centimeters. cubic centimeters. For the second one here, volume equals 1/3 pi r squared times height. And this time they give us the volume, 7,200, 1/3 pi, the radius is 15, squared times the height. And I start to simplify. So 7,200, 1/3 times pi, 15 squared is 225 times the height. I can do 1/3 of 225 is 75, so 7,200 equals 75 pi times the height. Well, I want to get height by itself, so I divide both sides by this 75 pi. And the height equals 7,200 over 75 pi, which actually does go in evenly. 75 goes into 7,200 96 times. So it'll be 96 over 1 pi, or just over pi. And those are yards, not yards cubed, because we were just finding the height. 96 over pi yards. So now you should be able to go over and do journal page 356, where it's just talking about the volume of cones. And you will use this formula, 1/3 equals pi r squared times height, to either find the volume if they give you the radius and the height, or find the height if they give you the volume and the radius. And we've just gone over a couple examples of either of those.